Solve each system graphically, identify each system as consistent or inconsistent, clearly label and scale the axes. Check the solutions when possible by substituting into the original equation. Alright, so we have 3x plus 2y equals negative 2. I'm going to convert that to slope-intercept form. So I would write 2y equals negative 3x minus 2. I subtracted the 3x from both sides. And now I'll divide through by the 2 each term. And so that would give me then y is equal to negative 3 halves x minus 1. So using a standard scale, one for each mark, so I have y equals negative 3 halves x minus 1. I plot the y-intercept at negative 1, and then I use the slope of negative 3 halves to let the line fall 3 and run 2. And I'll do that again, fall 3 and run 2. Now I'll draw the line through those points. Alright, and in red for the second equation, notice it's already slope-intercept form. So plotting the y-intercept at 0, 4, and using the slope, hey, the slope's the same, negative 3 over 2. So from that point, let it fall 3 and run 2. Let it fall 3 and run 2. And again, I'll draw the line through those points. But you may already be saying to yourself, well, wait a second, those lines are parallel. Parallel lines aren't going to intersect. So what we would have to say is, since they don't intersect, there is no solution. This system has no solution. And when this happens, we call this system inconsistent. Alright, so let's look at another one. Here we have a y equals 4/5 x plus 2 and negative 4x plus 5y equals 10. So let's graph the first one. Notice it's already in slope-intercept form, so I'll graph this line in blue. It has a y-intercept of 2. So let me put some scale on this. Alright, so we have a y-intercept of 2. Let me plot that. And then the slope is 4/5. So let the line rise 4 and run 2, 3, 4, 5. That would be a second point. And I'll use those 2 points to draw the line. So there's the line. Alright, now I'll work in red for the second equation. Negative 4x plus 5y equals 10. I'm going to go ahead and put it in a slope-intercept form. So let me add 4x to both sides. That would give me 5y is equal to 4x plus 10. And then I'll divide through each term by 5. And so y would equal 4/5 x plus 2. And it's the same line. So I would draw over that same line, but now in red, and I'll do my best to do that. So here we have the same line. So when that happens, we say that the system has infinitely many solutions. because each one of those points on the line is a point of intersection, right? Because those two lines are, in a sense, right on top of each other. So each one of those points is a point of intersection of the two lines. So this system is called consistent and the lines are called dependent. And so, or the lines are the equations. All right, let's look at one more. Y equals negative 5/4 x plus 2, 3x minus 4y equals 24. So again, I'll graph the first line in blue. Negative 5/4 x plus 2. So I get my scale on the grid. And we have, let's see, negative 5/4 x plus 2, so plus 2, and then the slope is negative 5/4, so let it fall 5 and run 4. So there are 2 points on the line. And drawing the line through the points. And the second equation, 3x minus 4y equals 24. Let me put it in slope-intercept form. I'll subtract 3x from both sides. Negative 4y is equal to negative 3x plus 24. And dividing through by negative 4 each term. Y would equal 3/4 x minus 6. So plotting the y-intercept at 0, negative 6. And then using the slope is 1 up 3 and right 4, and drawing that line. And so we can clearly see a point of intersection at 4, negative 3. Let's check the solution by substituting into the original problem. So, into the first equation, is negative 3 equal to negative 5/4 of 4 plus 2? We have the negative 3 on the left. Negative 5/4 times 4 is negative 5. Negative 5 plus 2 is negative 3. So that checks out. Into the second equation, 3 times x, so 3 times 4, minus 4 times negative 3, is this equal to 24? So that would be 12 minus negative 12. And is that equal to 24? And 12 minus negative 12 is 12 plus 12, which is 24. And so 24 does equal 24. And so the solution is 4, negative 3.